Good evening, everyone. Hello. Am I audible?
Yes, ma'am.
Okay. Okay. So, how are you all? All good?
Yes, ma'am. How are you?
Yeah, I'm good. I'm good. Okay. So, today we have week 11 session. Okay. So, have you guys gone through the lectures of week 11?
Ma'am, I haven't yet.
Okay. What about others?
No, madam, not yet.
Not yet.
Yeah,
I was
not yet.
waiting
Yeah.
for your class. Once this class is over, I don't think the videos are required to be watched. But it's my personal opinion.
Hmm. Like after the open session, you will go through the lectures like that.
If it's required, otherwise, if I'm able to solve the GA and PA,
Questions?
then I don't see.
Hmm. Okay. 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 That's fine. Okay, so shall we start with the session or should I wait for a few more minutes? How many people are there? There are 11 people. Okay, let's start with the session. Okay. Okay. So in week 10, we learned about the discrete random variable, right? Their expectations, how to calculate the expectations, how to calculate the variance and everything. So now we are going to learn about the discrete distributions. Okay. Okay, in this discrete distributions, we have few distributions like we are going to learn about four distributions. So the first thing is the Bernoulli trial. Okay, then the second one is binomial distribution. Then the third one is hypergeometric. And the fourth one is the Poisson. Okay, these four distributions we are going to learn in week 11. Okay, so let's start with the first one, which is the Bernoulli trial. Okay, do you guys have any idea what is Bernoulli trial? Any idea? Like a little bit? Any clue or anything?
Ma'am, it will have two values, success and fail.
Huh. Yeah, correct. So Bernoulli trial is a trial. So these are my experiment, or you can say the trials, in which I have we have two you can say two outcomes. Okay, which is basically one is my success. Okay. And the other one is failure. Okay. Okay. So these are my. So this is the main thing. So in a Bernoulli trial, I should have two things, which is a success and a failure. If I have two outcomes like this, I say it's a Bernoulli trial. Okay. So let's take an example. Example like if I'm tossing a coin. Okay. So if I'm tossing a coin, what are the two outcomes that can I have?
Head and
Head
tail.
and tail.
Head and tail, right? So I can have a head, I can have a tail. So in this case, I can have, so let's suppose my success is basically getting a head. Okay, so this is my success. So what will be my failure?
Getting a tail.
Getting a tail. So this is what. So experiment in which I can bifurcate my two outcomes into two things, which is a success and a failure. Then only I can say that it is a Bernoulli trial. Okay, so I say that. So let's suppose my X is basically getting. So X. So I say that my X is a Bernoulli trial. Okay, and I write it like this: Bernoulli with parameter P. So this P is actually denoting the probability of success. Okay, so this is how I denote a random variable with a distribution. So I say that my x is following a Bernoulli distribution with parameter p. So in the brackets, we generally like the parameter. So these are my parameter. So the parameter here for Bernoulli is p, which is denoting my probability of success. Okay. Now, I am saying that my x is following a Bernoulli. That means my x can have two values. That means 0 and 1, in which my 0 is denoting what? The failure, and my 1 is denoting the success. Okay. And we know that my x is a random variable. For each random variable, we have a probability associated with it. Yes or no? Yes or no? I'm not able to hear anyone if someone is saying something.
I didn't get you. Yes.
From where?
And the question you asked wasn't clear to me actually.
Okay, I am saying that my x is a random variable which is following a Bernoulli distribution with parameter p. So I'm saying that my x is a random variable, right? So, and it's following a Bernoulli. That means I can have two outcomes, failure and a success. So I'm denoting my failure with 0 and my success with 1, correct? So that means my value that x can take is 0 and 1. Till here it's fine?
Yes, ma'am.
Okay. Now I am saying that my x is taking value 0 and 1, and x is a random variable. And we have learned that for each random variable, we have a probability associated with it. Yes.
Ma'am, 1/2.
1 by, no. We will be talking about in general. Okay. So the probability is also, if my x is taking value 1, which is success, and we know that the p is denoting my probability of success. So the probability that my x is equals to 1 will be p, and the probability that x equals to 0 will be 1 minus p. So this is what my PMF is. Okay. If my, so probability that my x is equals to 1 will be equal to p, and the probability that my x equals to 0 will be 1 minus p. So this is what the PMF is for a Bernoulli random variable. Till here it's fine.
Yes, ma'am.
Okay. So now if I have to calculate the expected value, how will I calculate? What is the formula of an expectation?
Is it NP, ma'am?
Yeah, it will be NP. Correct. How we got this? It is what is my expectation? Expectation is basically summation of xi into the probabilities. Correct. So my I is going from what? 0 to 1. So this will be what? X taking value 0 and the probability at x0 plus x1 probability x equals to 1. Then it will be 0 into 1 minus p plus n, sorry, x1 is 1 into p. So this will be my p. So we have that my expectation is equal to t. So this is what is the expectation for a Bernoulli trials. Okay. Similarly, we can calculate the variance. Variance will be what? Expectation of x square minus expectation of x whole square. Okay. If we calculate this, we get my variance as pq, or you can say p into 1 minus p. This is what my variance is. Till here, is Bernoulli trial clear?
Yes, ma'am.
Sure, everyone? Okay, can I I'll ask one question. So at what point, at what value of P, I will have the largest variance, or you can say the maximum variance?
0.5.
Correct. My maximum variance will be at the point when my P is equal to 1 by 2. Okay, p equals to 1 by 2. That means that the probability of success is 0.5. That means I have half probability that it can be a failure, it can be a success. So it denotes that it is having a maximum variance or maximum variability, you can say. Okay, so this is what my Bernoulli distribution is. Bernoulli distribution is basically that an experiment in which I have two outcomes, it should be a success and a failure. If I have two outcomes, then only I can say it's a Bernoulli distribution. Okay. Now comes the other one, which is my binomial distribution. Okay. So what is a binomial distribution? Before that, there is one topic which is known as IID trials. Okay. What is IID? IID means independent and identically distributed trials. Okay. Like from the definition or from the you can say the heading, can you tell me what do you mean by IID trials?
The outcomes are independent, ma'am.
Huh. Okay, let's take an example. I'm tossing a coin. Okay, I'm tossing a coin. Okay, so this is my first toss. So I'm getting a head and a tail. Okay, then again second toss in which I can get a head or a tail. Third toss, I can get head and tail. Similarly, I can have n toss, okay, in which I can get head and tail. And for each of the tosses, I know that the probability of getting a head is 1 by 2 and probability of getting a tail is 1 by 2. Similarly, for the second toss also, I'm having the same distributions, correct? Yes or no? Till nth. So how many tosses? If I do n tosses also, I'm having the same probability. That means my x is so if my x is taking 0 and 1, the probability for the first toss is basically 1 by 2, 1 by 2. Okay. Now, similarly for the second toss also 0 and 1, my probability will be what? 1 by 2, 1 by 2. So nth toss also I can see that my x is taking value 0 and 1 and the probability associated with will be 1 by 2 and 1 by 2. For each of the tosses I can see I have the same probability distributions. Yes or no?
Yes, ma'am.
Yes. Yes. So I say that they are identically distributed. That means, what do you mean by identically distributed? That means for each of the cases, for each of the experiment, I have the same distribution. Then I say they are identically distributed. Now comes the topic independent. What is independent? We see that if I toss the coin first time, I can get a head or I can get a tail. Then the second time when I toss it, it does not depend on the first toss. Correct. I can, in the first toss, I'm getting a head. In the second toss, I'm getting a tail. So this tail is not dependent on the head, on the first toss, right? It's independent of the first toss. Similarly, my third toss is also independent of the second toss. So I say that these experiments are basically my independent experiments. Okay. So then I say that these are my IID trials. That means they are independent and identically distributed. That means all my trials are basically independent and each of the trials are having same probability distributions. Is that clear?
Yes, ma'am.
Okay. Okay. So this is what basically my IID trials. Now here comes in binomial. What do you mean by? Now comes the binomial distribution. So basically my binomial is, give me a moment. Okay. So my binomial is basically having n independent trials having success and failure. Okay. If you remember in the Bernoulli, we have only one trial which was having a success and a failure. Here now we have n independent trials which are having success and a failure. So, okay. So I say that my x is basically the total number of success that occur in n trials. Okay, so let's suppose I am having n trials. Okay, so I have x1 trial, x2 trial, x3 till xn. So my x will be equal to the sum of all the success that are happening in my n trials. So this is my x. So now I say that my x is following a binomial distribution with parameters n comma p, where my n is the number of trials and my p is same as the probability of success. Is binomial clear?
And the difference between the two is just about the number of trials, right?
Is the number of trials, yes. See, Bernoulli is considered only when I have only one trial which is having a success, like only if I'm tossing a coin one time, if I'm rolling a die one time. Okay, so then only I can have two things, which is a success and a failure. Okay, but my binomial is basically I am having IID trials, okay, IID Bernoulli trials and IID trials, which is having success and a failure. So my X is basically the total number of success that are happening in the N trials. So X will be basically what? X1 plus X2, X3. I will be calculating, I will be adding all the success that I'm having in the N trials. So then it is known as my X is following a binomial distribution with parameter N comma P, where my N is the number of trials and P is the probability of success. Clear?
Yes, ma'am.
Okay. Now we have, so for the Bernoulli, we had the PMF, right? So now for the binomial case also, my PMF or the probability will be NCX p raised to the power x 1 minus p raised to the power n minus x. This is what my probability distribution is for a binomial distribution. Okay. So what does this means is n is basically the number of trial and x is the number of success. Okay, so I am saying that from the n trial I have to choose x success into p, which is the probability of success, which will be multiplied x times into 1 minus p, which is the probability of failure, which will be multiplied n minus x times. So if I say that probability x equals to 1, that means that I have one success. So it will be NC1. So from the n trials, I have to choose one success into p raised to the power 1, 1 minus p raised to the power n minus 1. Got the point?
Yes,
Is
ma'am.
this thing clear? So this is what my distribution is, binomial distribution. Okay. Okay, let's see if we have a question. Let's take one question from the activity. One second. Mm, Okay, let's suppose I'm tossing a coin. Okay. Let's three times. Okay. And probability of getting a head is basically 0.5. And similarly, my probability of getting a tail will be 0.5. Now I have to check. So my x is basically the number of times uh, head is occurring. Okay. So now what is the probability that my x is equals to 2? See, what is the question is
It is
I'm tossing a coin
3C2
three times.
into, let's say, half raised to
Sorry?
2, like 3C2, 3
Hmm.
combinations, yeah,
Yeah.
into 0.5 raised to 2
Power 2 and
into
0.5
0.5
raised to
raised
the
to 3
power
minus 2.
1.
Yeah.
Yeah. So it will be 1. So this is how I calculate. Okay. So basically my x is following a binomial distribution with parameter 3 comma 0.5. So this is how I write. So this is my n, this is my p. So in the question they will be just writing it down that x is following a binomial 3 comma p, then find out the probability that x equals to 2 or x equals to 3, something kind of like that. Okay, we can have a questions like that. Okay, so this is how you solve for a binomial distribution. Clear?
Yes, ma'am.
Okay, so binomial, I guess is clear. Okay, now comes the expectation. Okay, expectation for a binomial. We know that my x is basically what? The sum of all the successes that are happening in n trials, right? So if I want to calculate the expectation of x, it will be what? Expectation of x1 plus x2 till xn, right? Now they're independent, so I can say that expectation of x1 plus expectation of x2, it will be equal to all the individual expectations, correct?
Yes, ma'am.
Yeah. So now, what will be this value? Expectation of x1.
One, ma'am.
Sorry.
P, that would be P.
See, I know that my x1 is a Bernoulli trial, right, with parameter p. My x2 is also a Bernoulli trial with parameter p. If my x1 is a Bernoulli, the expectation of x1 will be what?
0.5.
P?
Yeah, that would be P.
Just general. Okay. Similarly, expectation of x2 is p. What is my x? X is I'm just adding all these x in Bernoulli trials. Okay, to make it x, which is a binomial. So these are my independent trials. These are my independent trials, Bernoulli trials. I'm adding all of these to make a binomial distribution. Okay, so my
Ma'am, will it
expect.
be NP?
Sorry.
I asked whether it would be NP.
Yeah, it will be NP, right? So this is my expectation of x1 will be p plus p. So I will add it n times. So it will be NP. So I see that my expectation is basically NP. I'm adding it n times. Okay. Similarly, I get my variance to be NPQ, or you can say NP1 minus P. Is this thing clear?
Yes,
Is expectation and variance fine? Yes or no?
ma'am, could you
Everyone?
please explain the
Yeah.
variance once more?
See, variance you can just calculate simply, right? Variance is what? Expectation of x square minus expectation of x whole square. You know this formula. Or what else you can do is, you know variance of x will be what? Variance of x1 plus x2 till xn, correct? And we know that they are independent IID, right? So I have one rule that if my x, all the samples are my IIDs or independent, then the variance of the sum of these samples will be equal to their individual variances, correct? Sum of their
Yes,
individual variances. And we know that the variance of x1 is basically what?
P n minus P.
That means PQ, right? Similarly, PQ, this will be n times. So this will be what? NPQ, or you can say NP1 minus P. Got it?
Yes, ma'am, clear.
Okay. Yeah. So this is what my expectation and variance is for a binomial distribution. Okay. So if I say that if my x is following a binomial distribution with parameter 500 comma 1 by 2, can you calculate the expectation and the variance? Tell me the expectation and variance both.
Ma'am, expectation will be a multiplication of both. 500
Yeah.
into
So
half,
it will be
250.
250, and variance of x.
Variance will be 250 times 0.5.
So it will be 125.
125.
Okay. So this is how you calculate the expectation variance for a binomial distribution. Clear?
Yes, ma'am.
Okay. Now let's take one another example. If my x is following a binomial distribution with parameter 10 comma p, this is a question. Okay. And we know that my expectation is equal to 6. What is the value of p?
0.6.
0.6, right? How? We know that expectation is np equals to 6. We know the value of n, which is 10p equals to 6. So p will be 0.6. Clear? So we can have a question in which my p is not there or my n is not there. Then you have to calculate the value of n or you have to calculate the value of p. So with the formula, you should know the formula. What is my variance? What is my expectation? And equate those equations and solve the questions. Okay.
Ma'am, will the questions be this straightforward or will there be other situations as
It
well?
won't be. See, in this example that I'm telling you, I'm just straightforward. I'm telling you that x is following a binomial. They won't be saying that x is following a binomial. They will just give you an experiment, or you can say a question. Like I'm tossing a coin and I'm getting a head. Like 8 times, I'm getting a head or something, and then you have to calculate the probability that there are 7 heads or something like that. So they will give you a question like this, like situation based. They won't be giving you direct. Okay.
Okay.
So you have to find out whether it's a binomial, it's a Bernoulli and all. Okay. Clear?
Yes, ma'am.
Okay. And one more thing. There are few points. If I have small n and p is less than 0.5, then I have a right skewed graph. Right skewed graph in the sense that I will be having a graph like this. Okay. In the shape kind of like this. Okay. Now next is, if I have a small n and my p is equals to 0.5, I say I have a symmetric graph. Okay. What do you mean by symmetricity? Symmetricity in the sense I will have a graph like this. Okay. Now the third thing is, if I have small n, my p is greater than 0.5, I say I get a left skewed graph. That means I will have a graph like this. So this is what my graph represents. If I have a small n, okay, and my probability of success is less than 0.5, I say I have a right skewed graph. Do you guys know what is right skewed, symmetric, or left skewed?
Yes, ma'am.
Yeah. Okay. So this is what. So if I'm having n small and p is less than 0.5, I will be having right skewed. If it is equal to 0.5, I will be having symmetric, okay, distribution. And if my p is greater than 0.5, I say it is a left skewed. Okay, so this is how my graph represent when I'm having a binomial distribution with a different n and different p. And the main thing is, if I increase, or you can say for large n, if my n is large, very large, okay, large n, then my binomial, then all my distribution will be symmetric. Okay, these are my some cases, or you can say some properties, or you can say the effect of n and p on the graph. Clear?
Ma'am, up to what number will n be considered small?
See, here we are, so n is like greater than 30, or like if we increase the n small little by little, like if suppose small n in the sense I have four trials, if I have 5 trials, 6 trials. So if I increase it till 10, 11, if I increase little by 40, 100, 500, so I will have a symmetric graph like that. Okay. So this
Yes.
was all about the binomial distribution and the Bernoulli. Okay. So can you tell me the difference between the binomial and the Bernoulli?
Ma'am, it's about the number of trials. In
It's about the
Bernoulli,
number
it's
of.
only one trial, and here we get multiple trials.
Yeah. Okay. So the main thing is for the binomial thing, you should know the n. Okay. If there is no n, that is not my binomial. And in my Bernoulli, I should have only one trial, but I should have two outcomes, which is the success and the failure. Okay. Yeah. So is binomial clear to everyone?
Yes, ma'am.
Yes, ma'am.
Okay. Yeah. Okay. Let's jump to the other distribution, which is known as the hypergeometric. Okay. What is hypergeometric distribution? Okay. In the binomial case, we were having, okay, in binomial, we had the IID samples, right? So that means I am doing any activity or any experiment with the replacement part, correct? If my experiments are with replacement, then only I can have independent trials, right?
Yes.
Correct. Now, there are cases in which I don't have identical distributions, or you can say they are not independent. Okay. That means I'm doing without replacement. I can have that kind of cases. Okay. If I'm having a cases in which my probability distribution is not same for each of the trials, then it's a hypergeometric distributions. Okay. So let's suppose I'm having a box, okay, in which I'm having 4 white balls and 3 black balls. Okay, so in total I have 7 balls in a box. Now, so I have to take out, uh, let's suppose I have to take out like 2 balls at a time. Okay, so what for the first thing is at the first trial, I can have 2 cases in which I can have a blue ball or I can have a white ball, correct? Yes or no?
Yes, ma'am.
Okay. Now in the second, like if I'm taking out in the second trial, I say that, see, it is without replacement. I'm not replacing it. I'm not putting the ball that I'm taking out, I'm not putting back in that box. Okay. So that means if have taken already taken out my black ball, so in the box I will be having 4 white balls and 2 black balls, correct? Now, in this case, if I've taken out white balls, so in this case, I will be having 3 white balls and 3 black balls. Correct?
Yes, ma'am.
Yeah. Okay. Now, in this case, also, I'm having 2 cases in which I can get a black ball, I can get a white ball. Similarly, I can get a black ball, I can get a white ball. Correct? These are my cases. Okay. Now, the question is here, how many, you can say, black ball do I have? Okay, so in this case, I see that I am having uh, x is basically the number of black balls. Okay, so I say that my x is equals to 2 here. Okay, and in this case, for both of these cases, my x is equals to 1, and for this case, my x is equals to 0. Correct? X is basically representing the number of black balls. So my X is basically 2. How? Because of the first trial I'm having, took out one black ball. In the second trial also, I took out 1 black ball. So in short, I have 2 black balls. Similarly, in this case, I have 1 black ball, then white ball, 1 white ball, and then black ball. For both of these cases, I have X equals to 1. That means I have only 1 black ball. Okay. Now, in the second case, in both of the trials, I'm just taking out 2 white balls. That means I don't have any black ball. So I can have 3 values that X can take, which is 0, 1, and 2. Yes or no?
Yes, ma'am.
Yes, ma'am.
Correct. Now, if you see in the in each of the cases. Okay, so this is my first case, this is my second, like taking out the balls. So in the first case, taking the probability of taking out the black ball is basically 3/7. The probability.
Yes.
Okay, similarly for the white ball it will be 4/7. Yes. Yeah.
Yes.
Okay, now for this case,
Yes, ma'am.
in the second case, the probability of getting a black ball will be 2/6.
Yes.
And for this white ball,
4/6.
it will be 4/6. Now for this case,
3/6.
it will be 3/6. And the last one,
Same 3/6.
3/6. Correct. Now, if I have to calculate x equals to 2, so this probability is basically will be what?
3/7 into 2/6.
Huh. 3/7 into 2/6. Similarly, for x equals to 1 will be what? 3/7 into 4/6 plus
Plus
4/7
4/7.
into 3/6. Now, for this case also, this will be 4/7 into 3/6. Okay, so these are my probabilities of getting the number of black balls in an experiment. So if you see here in this hypergeometric, what I told you that I will be doing without replacement, and for each of the cases, my probabilities are not same, right? Because in the previous one, if you see in the binomial one, I had the cases in which I had same probabilities for each of the trials. Yes. But here we see that in each of the trials, I don't have same probabilities. In first case, I'm having 3/7. In the second case, I'm having 2/6. It's not same. Yes or no?
Yes, ma'am.
Yes, ma'am.
Yeah. So this is what where my hypergeometric distribution comes in. If this is the case in which there are three things that you have to consider. The first thing, the population is being divided into two parts. Okay, so if you see here, my 7 balls had been divided into two parts, which is 4 white balls and 3 black balls. So I can divide my the balls into two parts. Okay, so this is the first thing. And the second case is that the probability distribution should be different for each trials. So these are the things. So these both, my population is being divided into two parts, and my probability distribution is different for each trials, or you can say my experiment is being done without replacement.
But we have to stick only 2 parts, right? It cannot be 3 parts.
3 parts? No, only 2 parts. Okay. So these are the points that you have to remember, whether, like, if you have to check whether it is following a hypergeometric distribution or not. Okay, so let's come back to the you can say the probability distribution of a hypergeometric. So I say that if I have n items, okay, if I have n items and I have to select small n items without replacement. Okay, and these n items are of two types. I'm having m of one type, and I'm having n minus m of other type. Okay, then if I have to find out probability x equals to x, that means I am getting x is basically denoting the number of items of type 1. Okay, so x will be what? My m cx n minus m n minus x divided by capital N Cn. So this is what my probability distribution is for a hypergeometric case. Okay, so this is my hypergeometric. So let's go back to this example. Okay, so in total, I had n is equals to 7 balls, correct? In which I had 2 balls, m is equals to 3 and n minus m equals to 4. M is basically denoting the number of black balls, and this is basically denoting the number of white balls. Correct? So what we had in the definition, that I'm having n items in which m is of one type, n minus m is of one other type, right? So n is 7, m is 3, which is of black balls, and is equals to 4 white balls. Till here it's fine?
And what did you write after type? Number of items of type?
1. Type 1 is the first type. Like in this example, I'm talking about the black balls. Okay? Is this clear? Till here it's fine?
Ma'am, how we know
Yes,
M
ma'am.
is black, ma'am?
How many?
How M is black? I mean, is there any question phrase is there that's saying that, or we need to
See,
select?
if my question is asking the number of black, see, in this example, we were talking about the number of black balls, right? How many black balls I'm getting. So that's why my M is, I'm denoting my M as black ball. And the other N minus M will be denoting the other type. Okay? Clear?
Could you once talk about the formula which you just stated?
Yeah, I'm just talking about that only. Okay, so now from these 7 balls, I have to take out 2 balls. This will be my N without replacement. Okay, now I need to calculate probability x equals to, that means the number of black balls that I'm getting. So x, what all values that x can take? X can take 0, 1 and 2. Correct? Yes or no?
Yes.
Okay. Now x equals to 0, that means I'm not getting any black balls in the 2 trials, right? So now first thing is, at the first trial, I'm taking out a ball. So that will be, okay. So the thing is, I'm having total 3 black balls and 4 white balls. That means in this first trial, that probability x equals to 0, I'm not getting any black balls. That means from the 3 black balls, I'm not choosing any black ball. Correct? The rest,
Yes.
the 2 balls will be only selected from the white balls. Right? Yes or no?
Yes,
Divided
ma'am.
by what is the total? It will be
7C2.
my
7C2.
7C2. So this is, if you see here, this is just the same thing. It is MCX n minus m n minus x divided by NCN. Yes or no? It's just the same thing.
Yeah.
Similarly,
Yes, ma'am.
probability x equals to 1. That means I'm taking out 1 black ball. I'm getting only 1 black ball. So I can have from the 3 black balls, I can choose 1, and the other ball will be selected from the other type divided by 7C2. Okay. Similarly, probability x equals to 2. It will be that the 2 balls are being selected from the black ball. From 4, it will be 0 divided by 7C2. Is this thing clear?
Yes, ma'am.
Sure, everyone? So if we calculate
ma'am.
this value will be equal to this thing that we have calculated. Same. Okay. So this is what my hypergeometric distribution is. Clear? Okay. Now comes my expectation. Okay. So the expectation of a hypergeometric is basically n into m by n. This is my expectation, and my variance of a hypergeometric is given by n into m by capital N into capital N minus m by n into n minus n upon n minus 1. So this is what my variance is. Okay, so if you want to just remember this, you can just typically like if you remember, see, for the binomial my expectation was n into p, right? So this is similar to that, n into m by n. So in p, this is actually my p is basically the proportion m by n. Similarly for variance, you know that my variance what, n into p, n into p into q, right? So this is n, this is p, and this is my q, which is 1 minus p. And I just have an extra item which is n minus small n upon capital N minus 1. Okay, so this is what my
Ma'am,
expectation is. Yes.
so I had a doubt relating to the comprehensive exams, if you could answer, or I can
Sorry?
take it up in the end. I had some doubts regarding the comprehensive exam. I can take it up in the end also if you want.
Yeah, yeah. Okay. So yeah. So this is
Ma'am,
what my hmm,
what exactly is the small n?
small n is the number of item that I'm taking out of the capital N, right? See, in this example, what is my small n? Small n is basically I'm taking out two balls, two black balls, or you can say two. So from this seven balls, I'm taking out two balls. So this is my small n. Okay. I'm choosing two balls from the seven balls. Is that clear?
Yes, ma'am. Ma'am, could you please read out the formula once for me so that I'm sure with the signs I have used?
The distribution one.
Yes, ma'am.
Okay. It is MCX n minus m uh, n minus x, small n minus x, divided by capital N C, small n.
So, ma'am, it is capital N minus m and small
Hmm.
n minus x. And
X. Yeah.
afterwards it's capital M C small n, right?
Yeah. Correct.
Okay, okay, thank you.
Okay. Okay. So what this is what all about hypergeometric distribution is. Is hypergeometric clear?
Ma'am, someone asked for the tree structure.
Sorry? Tree structure? What's the doubt?
And someone wrote in the chat that could you please show the hypergeometric tree structure?
Hypergeometric tree structure. Um, is he talking about this thing only? This one? I don't know. Is this the one that he is talking about?
Yes, ma'am. She wants to take notes actually.
Okay, okay. You can just take the screenshot if you want. Yes, taken. Shall we proceed? We just have one last distribution. Can I move forward?
And I think you can.
Okay. Now comes the last thing, which is Poisson distribution. Okay. So Poisson distribution is basically it is actually giving me it is the probability of number of events occurring in a fixed interval of time. Okay. This is what my Poisson distribution, like in this situation only, I use my Poisson in which I need to calculate number of events that are happening in a fixed interval of time. Then we use the Poisson distribution. Okay, so now I say that my X is following a Poisson distribution with parameter lambda. So now this lambda is basically my average rate. Okay, the average rate that my event is happening. Okay, so this is what my Poisson distribution is. Okay, and the PMF is actually given as e raised to the power minus lambda, lambda raised to the power x upon factorial x. So this is what my PMF is for a Poisson distribution. Okay,
And what is that in the denominator?
factorial x, or if you remember this thing. Okay, so basically it is denoting that it is the distribution which is denoting the number of events that are occurring in a fixed interval of time, and lambda is basically my average rate. Okay, and like if you just like let's suppose like we can take an example like the number of vehicles passing through a uh, toll booth in 1 hour. So I'm having, so this is basically what in a fixed interval of time, how many vehicles are being passed. So this is what my Poisson distribution is. Is it clear? When
Yes,
do we
ma'am.
use the Poisson distribution? Okay. Now we have the expectation and the variance. So my expectation is basically equal to lambda, and for variance is equal to lambda. So this is one distribution in which my expectation and the variance both equal to lambda. Okay. Clear?
Yes, ma'am.
Okay, let's solve some simple questions. So let's suppose my X is following a Poisson distribution with parameter 0.5. So this 0.5 is basically equal to lambda. Okay, now you need to calculate my probability that my X is less than equal to 1. Okay, so how will you calculate? This will be equal to what? Probability X equals to 0 plus probability X equals to 1. Yes or no?
Yes, ma'am.
Yeah. So this will be e raised to the power minus 0.5.
0
Yeah.
pi to the power 0 by
0 factorial.
0
Plus
yes.
e raised to the power minus
Minus
0.5, 0.5 raised to the power 1 upon 1
by
factorial.
1 factor.
Yeah. So this is how you solve the questions for the Poisson distribution. Clear? So this
Yes,
was
ma'am.
all
Yes,
about
ma'am.
in week 11. That's it. So these were all the distributions. So we were just learning about the discrete distributions. Okay. So the first thing was the Bernoulli trials. So Bernoulli trial are basically that trials in which I'm having only two outcomes. Okay, which is the success and the failure, like tossing a coin, or like if I'm uh, rolling a die. Okay, so for rolling a die, I have six outcomes, right? But I'm saying that my x is a random variable, which is that I'm getting a six as an outcome. So my success is that the six is an outcome, and failure will be not getting a six. So that is also my Bernoulli trial. Okay, so if my x is a Bernoulli trial, then I denote it as X is following a Bernoulli distribution with parameter P, where my P is basically the probability of success. And what is the PMF? PMF is basically X is taking two values, that is 0 and 1, and the probability is associated with will be 1 minus P and P. Okay. Now expectation will be P and variance will be P into 1 minus P. And where at what point I will be having the maximum variance, it will be P is equals to 1 by 2. Okay. Now comes the binomial distribution. Binomial is basically, before that, we need to know what is an IID trials. IID trials are basically independent and identically distributed trials. That means for each of the cases, I can have n trials, right? So for each n trials, I will be having same distribution. Okay, and each of the trial will be independent of each other. So then I say that they are my independent and identically distributed trials. Okay. Now comes the binomial. Binomial is basically I'm having n dependent trials which are having, so in each of the trials I'm having a success and a failure. So if you see here, in each of the trial I'm having two outcomes, which is success and a failure. So I say that my each of the trials are basically Bernoulli trials. So in that case, in that sense, I'm having n independent and identically distributed Bernoulli trials. So X is basically the total number of success that occurs in an n trials. So X will be what? X1 plus X2 plus X3, I will be adding all the success. So I say that my X is following a binomial distribution with parameter. So I'm having two parameters, N and P. N is the number of trials and P is the probability of success. And the PMF is given to be NCX P raised to the power X 1 minus raised to the power N minus X. Okay. And the expectation is NP and variance is NPQ. Clear? Now comes, okay. Now we have like, what is the shape? If I'm having small n and p is less than 0.5, I will be having a right skewed distribution. If I'm having p equals to 0.5, I will be having a symmetric graph. If p is greater than 0.5, I will be having a left skewed graph. Okay. And if I increase the number of samples, or you can say if I increase the number of trials, my binomial distribution or this graph will be going to be symmetric. Okay. So this was all about the Bernoulli and the binomial. Okay, now comes the hypergeometric distribution. Hypergeometric in binomial, we were learning about with replacement cases, in which I'm replacing it. That's why I'm getting identically distributed trials, right? Independent and identical. But hypergeometric is the case in which I don't have an independent, sorry, I don't have an identically distributions. The probabilities are not same for each of the cases, right? They are not independent. So then I have an hypergeometric case. So here my population is being divided into two parts, okay, which is like this, the first and the type 1 and type 2. And the probability distribution is not same for each of the trials in each of the samples, okay? Or you can say my experiments are basically without replacement. Then I have a case of hypergeometric distribution, okay? And the PMF is given to be MCX n minus m c n minus x divided by capital N c n. So this is what my PMF is for an hypergeometric case. Okay, and expectation is given to be nm upon capital N, and variance is given to be this. Okay, then the last comes is the Poisson distribution. Poisson is basically when I have to calculate the probability of number of events that are occurring in a fixed interval of time. Okay, that means the number of accidents that are happening in 1 hour, or the number of vehicles that are passing from a tool booth in 1 hour, or something kind of like that. If I have to calculate the number of events in particular time, fixed interval of time, then I have a Poisson distribution. And I denote my x is following a Poisson with parameter lambda, where my lambda is the average rate. And this is the PMF. And this is the distribution
Ma'am,
in which I'm having the expectation and the variance equal to lambda. Okay. So this was all about in week 11. Is week 11 clear to everyone?
So, ma'am, if like after like we try to solve this ourselves, there are still doubts, then we can clear them in the next instructor session, right?
Yeah, sure. So let's do some activity questions. Okay, 1, 2, 3 activity questions we can do right now. Okay,
Ma'am, I
because there
just
are
wanted to ask whether there is a good book you can suggest which would cover, most of stats on, maybe if it has stats too.
do
Because
hmm, do you, see the one book that is very like popular or very simple to understand is the S.C. Gupta, the fundamental of mathematical statistics. That is like the fundamental book of statistics. You can just go
w-
through that book.
would it cover all of our syllabus?
Stats one, yeah, it will cover.
Okay.
Okay.
Yeah.
Okay. Let's do some questions from the activity. Okay, let's take some few questions so that it will be easy for you to do the questions. So I'll just be taking 11.1 and 11.2 are like simple questions. You will be able to do it. Then from the probability exactly.
Ma'am, one question, please.
Sorry. Okay,
One question.
One. What's your question?
Ma'am, in some PYQs, the formulas are mentioned, and some it
Sorry?
is not mentioned. In some of the PYQs,
Hmm.
the formulas are mentioned, and in some it is not mentioned.
Okay.
So we will have the formulas or we will not have the formulas.
Uh, no, you guys won't be having any formula sheet. In stats one, there is no formula sheet.
Okay, ma'am.
Okay. Okay. Can you guys open the portal? Activity question 11.3. Have you guys opened it? Activity question 11.3, question number 5. Yes or no?
Bob, have these distributions now transitioned from descriptive statistics to inferential statistics at some level?
Yeah, so we are coming into inferential only. Yes. So that's when I told you, like when we started the probability thing. So for the inferential, we should know the first thing, the basic thing that we should know is the probability. So when we started week 7 only, the inferential thing started. Okay, the basic thing of an inferential statistic has been started, you can say. Okay.
Yeah.
Okay. So have you guys opened activity 11.3, question number 5?
Yes, ma'am.
Okay. Let's read that question. So the question is, suppose that 4.5% of people living in a particular city owns a Creta. A survey has been conducted to know what brand of cars people use in the city. What is the probability that the 12th person being interviewed during the survey is the second one to own a Creta? How will you solve this question? Any guys? Any ideas? Anything?
Ma'am.
Yes. Um, yes. Are you saying something?
Can you give it for
Sorry?
formula for the binomial?
Yeah, it will be. So they see what is my P is basically the probability that what is that they are owning a Creta. So what is the probability? Probability will be what?
No, it's 45,
0.
4.5%, so 0.045.
0.05. Correct. Now the case is they are saying that a survey is conducted in what brand this what is the okay, so so they are saying that my 12 what is the probability that my x is equal that the 12th man will be getting the second Creta. That means my from like before that the 11 people, from this 11 people, one person has got one Creta and the 12th person has got the second Creta. Yes or no? Yes or no?
Yes, ma'am.
Okay, so now I'm denoting that my x is basically the number of Creta owners, right? So I'm just denoting it simply the number of Creta owners. Okay. Now probability that my x is equals to 1. I'm just talking about from 1 to 11, because for the 12th we already know that the 12th man is already having the second krita. That means from 1 to 11 I have to search that one person who is having that one krita. So for that I will be choosing one person from that 11, and we know that the probability of getting a krita is 0.045 raised to the power 1. 1 minus that means 0.955 raised to the power 10. So this is what my probability is of getting exactly one krita out of the 11 people. Yes? Yes or no?
Yes, ma'am.
Okay. And we already know that a probability x equals to that the second person, the second krita is being owned by the 12th person, which is 0.045. That is the exact one, right? So the total probability will be 11C1 into 0.045 raised to the power 1, 0.955 raised to the power 10 into 0.045. Is this thing clear? Is this question clear to everyone?
Yes, ma'am.
Sure. Okay.
Now that you explained, it's clear, but I don't
Clear.
think if such question come in the exam, I will be able
See,
to
these
solve
type of questions won't be coming in the exam. Don't worry. Like it will be like a questions that you can solve it in the exam. Okay. So don't worry about it. But yeah, the activity questions, the practice assignment, and the graded assignment will be like tough questions so that you can do questions easily in the exam. Okay.
Okay, ma'am.
Okay. So let's see some more questions.
Ma'am, so the comprehensive exam will have the syllabus of the complete course, right? Week 1 to 12.
What do you mean by comprehensive exams? Right?
I mean the exam in May, the last exam
The end term.
for the end term.
Hmm.
We'll have the whole syllabus, right? 1 to 12
Yeah,
week.
yeah, correct. See, I don't know about the other subjects, but for stats, it's basically from week 1 to 12.
So, but
Okay.
what kind of weightage are we looking at the older weeks?
What kind of weightage? See, it will be so from week 1 to 8. The total is of 40 marks of paper, right? So from week 1 to 8, it will be like 20 marks, and from 9 to 12, it will be of 20 marks, like that.
So, sorry, can you please repeat that?
I'm saying that from week 1 to 8, it will be of 20 marks questions we will be giving. And from 9 to 12, we will be giving 20 marks of questions.
So it
Okay?
will basically be a 40 mark paper.
Yeah.
And it is double to convert it to 80, and the rest of the marks are from the extra activity.
Extra activity or extra activity are basically for the bonus and everything. After you give the end term and everything, we give you bonus mark. Okay. Okay. Can you guys open activity question 11.5? Question number 2. So they are saying that my x is following a binomial distribution with parameters n and p, and they have given you the expected value 6 and variance to be 3.6. Now you tell me the value of n and you tell me the value of p. Calculate and tell me the answer. Okay.
It should be 15 and 0.4.
15 and 0.4. Everybody is getting that answer?
Yes, ma'am.
Yeah. It is just that you have to solve the equation. We know that expectation is NP equals to 6 and NPQ is equals to 3.6. So in this, if you put 6 into Q equals to 3.6, Q will be 0.6. Okay. So Q, then that means my P is equals to 0.4. I have P equals to 0.4, so N will be 50. Okay. Now let's see some other question. Okay. Activity question 11.6. Question number 3. Open activity 11.6. Question number 3. So they are saying that suppose that I have 5 fruits are randomly chosen from a basket containing 20 fruits, right? So that means my capital N is 20 and my small n is 5. Okay, of which 16 are good and 4 are rotten. So I have two types. I have 16 good and 4 rotten apples, fruits. Okay, that y denote the number of rotten fruits chosen. So what will be my m here?
Four.
16.
Sorry,
Oh,
4,
sorry,
madam.
4.
M is
4,
4.
m is 4. Okay, so now you need to calculate probability y is equals to 2. That means I'm getting 2 rotten fruits. What is this value?
But 22.
Okay, let's go by the formula. Okay, so that means I need to have 4 rotten. That means from the 4 rotten I will be choosing 2. Okay, and the rest of the fruits will be taken from the good type. Correct? Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay, divided by the total.
20,
That means
20
25.
C5.
Okay, if you don't remember the formula, okay, you can just go through the topic. So what is it? I need to have 2 rotten apples or and fruits, anything. Okay, so I want to have 2 rotten apples. That means from the 4 rotten I will be taking out the 2 and the rest of the 3 will be taken out from the good apples, right? So this is the thing. This is what hypergeometric is. It's as simple as that. Okay, if you don't remember the formula, just go through by the definition. Okay, clear?
Yes.
Okay, so then let's see any other question. Uh, from yes, okay, activity question 11.7, question number 1. A box contains 7 items out of which 2 are defective. So I have 7 items in which 2 are defective. That means the rest of them are the good one. Okay. A sample of 4 items are to be selected randomly. So I'm taking out 4 items from it without replacement. X is representing the number of defective items in a selection of 4 items. Okay. So X is basically the number of defective items. So here, what is my N?
Oh, 7.
7.
7. Small n?
4.
It's 4.
M?
5.
2.
2. Correct. Now, what is the value of expectation of X?
N and
4
by
into
N.
2 by 7.
Sorry, it will be small n
Small n into
by
small n by
capital.
capital.
Yeah, so it will be 4 into 2 by
4 into
7.
2 by 7.
Correct. Okay. Okay, let's do another question. Question number 4 in that activity only. So Sumit, a fruit seller, has a crate which contains 250 green and 250 red apples. In total, how many apples do I in how many apples I have? For 500 apples,
500.
out of which 250 are my green and my 250 are my red apples. Okay. A customer comes to Sumit's shop to buy apples and select 5 apples randomly. So from this 500, I'm selecting 5. If the random variable x represents the number of green apples, so x is basically the number of green apples. In the selection of 5 apples, then find the value of variance of x. Okay. Now in this, what is my capital N?
500.
500.
Small n?
250.
Small n is
Sorry,
250.
5.
Hmm.
Five.
Small
ma'am.
n.
50.
200, ma'am.
Okay.
250.
250. So what is my variance of x? It will be n into m by n.
N
Huh?
n minus m
Into
n 1.
huh?
N minus N minus 1.
Sorry,
N minus m
N
divided by n
minus
minus
m
1.
by n minus 1.
n minus small n upon n minus
N
1.
minus 1.
So this will be 5 into 250 divided by 500 into 500 minus 250 divided by
500.
500 into 500 minus 5 divided by 500 minus 1. This is what my variance is. Okay. Let's see the other one. Um, Okay. Activity question 11.8, question number 5. The number of persons arriving per hour in an insurance company for the insurance for their car follows a Poisson distribution with parameter 6. So x is basically, what is my x is the number of person arriving per hour. Okay. So x
7
is following a
x.
Poisson distribution with parameter 6. That means this is my lambda. Okay.
11 is 6.
Find the probability that exactly 7 people will arrive during any 90-minute period. So if you see here, my lambda is basically per hour base, right? That means 60 minutes. But I need to calculate for the 90 minutes. Yes or no?
Yes, ma'am.
That means my parameter will change. So my lambda is 6 for 60 minutes. What will be a lambda for 90 minutes?
9.
It is 9.
Yes, ma'am.
Sure. Okay. So now I see that my x is following a Poisson
Ma'am,
distribution.
how is it 9? How did you get that?
See, okay, for 60 minutes, my average rate is 6. So for 90 minutes, what will be my average rate? It will be 6 by 60 divided by, sorry,
Okay,
into
ma'am.
90. Got it?
Yeah, good.
Okay. So now I have the new thing that my x is following a Poisson distribution with parameter. What will be my new parameter?
9.
It
9.
will be 9. So what is probability x equals to 7? It will be e raised to the power minus 9, 9 raised to the power 7 upon factorial 7. Clear?
Yes, ma'am.
Is this question clear?
Yes, ma'am.
Okay. Okay, and I guess the other questions and other activities are basically expectation variance. You guys can solve it. So yeah. So this was all in week 11. Is week 11 clear to everyone?
Yes, ma'am.
Yeah?
Yes, ma'am.
Yes, ma'am. Yes.
Is it confusing? How is it? How is week 11? New thing? Yeah?
Not confused.
Ma'am, I found it better than the previous
Yes, ma'am.
weeks.
Really? Okay.
Yes.
That's good to know. Okay, that's the first time I'm hearing. Okay, nice. Okay then. So yeah. So that was all in week 11. Any doubts? Anything specific?
So, ma'am, in the comprehensive exam, like how do
Yeah.
we clear the course? Like it is like 40% plus, right? In the end term
Yeah.
exam. So you have to get like the total course grade should be above 40% or
40,
end term
correct.
should
Total.
also. So end term could be less, like for instance, for me, both the quizzes combined to form more than 40. So essentially, if I get even zero in end term, I will clear
Oh, no, no, no,
the.
no. See, the end term is the most important. If
Okay.
if you're not giving end term, you are basically
Mhm.
failed.
No, that I understand. But
Yeah,
when you give end term,
yeah.
and you have, is there a specific threshold of marks you need to get, or you can just give the end term and get whatever marks and clear?
Mm, you have to get some, like, you have to get marks, right? So what basically we are doing is the total score is like 25% from the like
No, yeah, so I
30% from.
understand the grading,
Huh.
and that is why I was asking you to actually clear this for me, since because I read the grading policy and it says that, either they will take 30% from maximum marks of either quiz one or quiz two, whichever had more marks, and 60% from the final term, or they will
Correct.
take 45 from the final term and 25 from quiz one and 30% from quiz two. So
Hmm.
if you take the second method, which is 25 from quiz one and 30 from quiz two, which is obviously always a better method, I'm already getting more than 40% marks, right? So that
Hmm.
is why I was trying to understand whether how big of a, like, is there a threshold to get more than uh more than some required number of marks, the threshold marks in the final exam? Or is it that you give the exam, you get whatever marks, and since you're already getting more than 40, so you clear? I hope I'm able to convey what I'm asking to you.
Yeah, just asking that in the like in the final exam, if you get fail also, like if you get 0 marks also, like your marks is getting added, right?
Mm.
This like
Technically, he's right, madam. He should pass, but
yeah,
practically it
you
will not
should.
happen. Somebody is getting more than 14 first two terms. There is zero probability he will get 0 marks in the final term.
No, I know there is zero probability, but it is just
But
for the sake of my
yes,
understanding
yeah,
that
you are
whether
right.
there
Yeah,
is a
you
If you get
will.
threshold.
zero, you will pass.
Yes, of course you will pass.
Okay, so there's no
And
threshold
and
per se in
also,
the.
No,
mhm,
no,
and
there is
also
no
you're getting
threshold.
bonus marks and everything, no? So the total
Yeah,
grade will be like adding everything.
yeah. Okay,
Hmm.
so that is what actually I was trying to understand. Obviously, I'll not get zero and I'll not go for zero, but there's
Yeah.
something that I had to understand. And also,
Yeah.
what if someone like doesn't, like, someone gets less than 40, what happens then? Do they fail the course and they have to retake that whole course?
Yeah, they have to
Or
retake
or
it,
do
no?
do they get another chance at the exam?
Yeah, they will another chance. I don't think so. They will get another chance.
No,
Like a
you have to
re-enter
pay
or
full
something.
fee and again repeat in the next term.
Repeat.
So
Yeah.
you have to repeat from quiz one in the next
Yeah,
term.
yeah, correct.
Hmm. Correct.
Okay.
There is no kind of supplementary which used to be in earlier so that you can re-exam and pass. Though you have to pay full
Yeah.
amount and repeat.
Okay. Yeah, thank you so much. That
Yeah.
is what I actually wanted to clear because, well, anyway, thank you. So there is no threshold per se in the final exam, right?
No, no, no.
No.
So it is purely for your grading and your CGPA.
Hmm.
Okay.
Okay. Anything else?
Thank you. Thank you so much.
Yeah.
Yeah, thank you.
Okay, so that's all, I guess. So thank you, everyone. Have a great night. Okay, go through
Thank
the
you, ma'am.
lectures if you want. Go through the lectures
You
once
too.
again. Okay, and on Tuesday we will be having the doubt session. Sunday there is no session. On Tuesday direct we have a doubt session. Okay.
Yes, ma'am.
Okay.
Thank you.
On, sorry,
Okay.
which day we don't have class?
Sunday.
So, so
Uh,
open
We have
session
three.
that day is cancelled.
See, we have three sessions, right? Open session
Hmm.
and solve with a session and doubt session. So now we will be
Hmm.
having only two sessions, which is the open session and the doubt session.
So
Okay.
open session today, of
Yeah.
Friday, and
So
Tuesday.
on
That's
Tuesday we will be having doubt session. Okay. So it depends. Like sometimes we can take it on like the open session can be taken on Sunday also. Like it depends upon the instructor to instructor. So I took it on Friday and I will be taking the doubt session on Tuesday. Okay.
Thank you so much. Thank you.
Yeah. Okay. Yeah.
Thank
Bye
you.
everyone. Yeah. Welcome. Have a great night. Bye everyone. Good night.
Good night.
Bye, ma'am. Good night.